speedier than the genuine development of spacetime itself, it can stay aware of its cognizance of it. Hence, it will progressively destroy this thought, filling me with a sensation of disquiet. At this point, our night sky is rapidly changing, and inside the following couple of decades, perhaps sooner, it could become absolutely unrecognizable. Experts, including Neil deGrasse Tyson, are sounding the alarm about the undeniable changes brought on by the shifting of Polaris. The foundational reason for this change is surprisingly unexpected. Polaris, generally known as the North Star, has been a reliable tool in the sky for a long time, serving as a principal reference point for astronomers, pilots, and stargazers alike. However, this could soon be altered, affecting the way we see the sky and study the universe. For centuries, Polaris has been a guiding light for sailors and astronomers, standing firmly positioned in the sky. Its steady presence has been essential for navigation, yet this stability may soon be disrupted. A paper from the prestigious Royal Astronomical Society, published in September 2023, raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one where it could eventually explode, disappearing from sight forever and altering the sky as we know it. Before considering the potential consequences of this event, let us delve into the characteristics of the star itself. Polaris is notable due to its proximity to the celestial North Pole, positioned directly above Earth's northernmost point. It appears almost unmoving in the sky. Located in the Ursa Minor constellation, commonly known as the Little Dipper, Polaris shines with moderate brightness, resembling a yellow-white supergiant star that is much larger and brighter than our Sun. However, Polaris is not just a single star. It is part of a complex triple star system consisting of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behaviors, and disturbances in their interactions could cause shifts in brightness or pulsation patterns. Nonetheless, the exact nature of these forces is still not fully understood. Polaris is located approximately 3,223 light-years from Earth, meaning the light we currently see from it began its journey a long time ago. If Polaris were to explode, we wouldn't see the effects for over 300 years. It's even possible that Polaris has already exploded, but we have yet to observe it. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its constant position has made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris has represented stability and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has been a crucial reference point in studying celestial movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided vital insights into the properties of stars and the behavior of variable stars. This characteristic has also been key in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm, making its behavior easier to forecast. Recently, however, Polaris has started to show signs of deviating from its standard behavior. This irregularity in its pulsation cycle has intrigued astronomers, prompting further investigation into the cause of these unusual changes. Instead of adhering to its usual pattern, Polaris has begun to exhibit unpredictable dimming, raising concerns that the star might be nearing the end of its life cycle. This behavior aligns with what is observed in stars approaching their final stages. The gradual increase in Polaris' pulsation period, when consistent, has been traced back to interactions within its star system. There has been an annual increase of around 4.5 seconds in the pulsation period. While this may seem minor, it carries significant implications. Some astronomers suggest that gravitational forces between the stars and the Polaris system could be driving these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they may be approaching a dramatic explosion. Stars nearing the end of their life cycles often exhibit such irregularities before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star approaches the end of its life, it undergoes several stages, including the red giant phase and eventually a supernova explosion. Given the irregular pulsations observed in Polaris, scientists anticipate that it has entered the phase of helium depletion, which is typical for giant stars nearing their end. These abnormalities align with patterns observed in stars on the brink of a supernova. However, strong evidence of an impending supernova remains uncertain, and astronomers continue to monitor these phenomena to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a spectacular event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brightness could significantly alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays an essential role. Fortunately, Earth would likely remain unaffected, given its size and distance from us. While the explosion of Polaris might not be as visually dramatic as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. This would undoubtedly capture the attention of astronomers and observatories, generating widespread interest. The potential explosion of Polaris would not only change the night sky but also offer significant scientific opportunities. Supernovae are rare events in the Milky Way, and observing one in real time could provide astronomers with valuable data. Scientists could study the physical processes that occur during such explosions, gaining insights into the life cycles of stars, the formation of heavy elements, and the dynamics of celestial systems. Polaris' location in the northern hemisphere makes it particularly significant, as it is easily observable from many advanced observatories around the world. A supernova event in Polaris could also help refine existing models of stellar evolution and recalibrate cosmic distance scales, as its nature as a Cepheid variable star already plays a critical role in these areas. On a cultural level, the disappearance or transformation of Polaris could affect its symbolic value. For centuries, it has been an unwavering guide, representing consistency and direction. The loss of such a prominent celestial marker could inspire a re-evaluation of its place in mythology, navigation, and humanity's history. Looking beyond Polaris, this phenomenon highlights the ever-changing nature of the universe. Stars are born, live out their lives, and eventually die, often in spectacular ways. The changes in Polaris remind us of the dynamic processes that govern the universe and the interconnectedness of all celestial bodies. In preparation for this potential event, astronomers and observatories continue to monitor Polaris closely. Instruments capable of detecting changes in brightness, pulsation, and other characteristics are being used to gather as much data as possible. These findings could not only help predict the star's future, but also contribute to broader scientific advancements. In the meantime, the North Star continues to shine brightly, serving as a reminder of both the stability and the transience of the universe. Whether it explodes in our lifetimes or remains a steady guide for generations to come, Polaris will always hold a unique place in the story of the universe, captivating interest both in the academic community and among stargazers. The impact on Earth's environment or climate from a Polaris explosion would be less significant compared to a supernova closer to our planet. But what will happen to Polaris itself? What is its fate after a potential supernova explosion? First, it's essential to note that while massive stars typically end their lives in a supernova explosion, this isn't likely for Polaris. When a massive star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to disintegrate. However, Polaris isn't massive enough to experience such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This transition won't lead to a supernova but will result in a quieter end. Polaris will evolve into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium mass star that has expended its nuclear fuel. This remnant, though roughly the size of Earth, will still possess the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris explosion with those of actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate destinies. For instance, supernovae like SN 1987A, SN 2011FA, and SN 2014J have provided significant data that help us understand what might happen to Polaris in the future. For example, SN 1054 resulted in the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, offering astronomers a rich field of study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided critical insights into nucleosynthesis and the mechanics of supernova remnants, including nebula formation and energy dynamics. Even if Polaris doesn't undergo a dramatic supernova explosion, its evolution into a white dwarf would still mark a significant chapter in the history of the cosmos. The study of this transformation would enhance our understanding of stellar life cycles and the ongoing changes in the universe, reminding us of the intricate and ever-evolving processes that govern the stars above. As Polaris evolves into a white dwarf, it will no longer be the bright, steady beacon we know today. While its transformation may not produce the dramatic visual spectacle of a supernova, the scientific implications of this change are still profound. The study of white dwarfs, especially those that were once Cepheid variables like Polaris, can offer crucial insights into the end stages of stellar evolution, providing astronomers with valuable information about the fate of stars similar to our Sun. White dwarfs, despite their size, are incredibly dense, with the mass of the Sun packed into a volume similar to Earth's. As they cool and fade over billions of years, they become increasingly difficult to detect, and their light will dim until they eventually become black dwarfs, objects that emit no visible light. The transition from Polaris' current state to this eventual fate will take millions to billions of years. During this time, however, astronomers will continue to monitor the changes in its brightness and pulsation patterns, gaining further understanding of the processes at play in such stars.